Scientific notation. The big idea for the last several weeks has been, how do you write numbers in different ways? And why is that helpful? Well, we are going to learn how to write things in scientific notation, but also how to be able to read numbers that are written in scientific notation. All right? So, as remember, the I can statement that we covered, the goal is to be able to write large and small numbers using scientific notation. Well, how do we do that? Well, we need to remember this. When a number is written as the product, okay, product means what's happening there? Multiplication, right? When it's written as a product of a factor and a power of base 10, the factor must be between 1 and 10. All right. Well, what does that mean? Take a look at example 1, please. We have, we're going to start by looking at numbers that are already written in scientific notation, and how do we write them as regular numbers. So I have 5.34 times 10 to the 4th. Okay? Now, what I need you to remember is that if the exponent is positive, then it is going to be a large number in standard form. If the exponent is negative, we're going to have a small number, okay? So I need you to remember these hand signals for me. If you're watching the video, you won't be able to see them, but try this again. Spread your arms out wide. If we have a large number, okay, it is a positive exponent. A small number is a negative exponent. So just by looking at 5.34 times 10 to the 4th, what kind of exponent do we have? What kind of exponent do we have? Positive or negative? Positive. Therefore, according to the little thing you just did, this can be a big number or a small number. A big number. Now let me ask you this. Which way would I have to move my decimal point to make it a big number? To the right. And how many spaces am I going to move it? I'm going to move it 4. Because, let's look at this really carefully. Another way that we can write 10 to the 4th is what? It's 10,000, right? Or 10 times 10 times 10 times 10. And every time you multiply by 10, you move something to the right. So now we can just focus on this exponent, and it's going to tell us how many times to move our decimal point. What we have to know is which way do we move it. And that's where recognizing the positive or negative helps. Okay? So I have 5.34. I'm going to move it 4 spaces to the right. So I've got 1, 2, 3, 4. Now I've got this decimal point kind of out there in the middle of nowhere. What do I do with these empty spaces? Okay? We're going to put zeros in them. Okay? Now, one teacher I had growing up said, kind of picture them as egg cartons, right? And if you have empty egg cartons, you have to put eggs in them. And I always thought that that was kind of funny. So remember, if you have empty egg cartons, put eggs in them. So the answer, after I rewrite it now, is going to be 53,400. 53,400. All right, let's do one more. All right, I have 9.62 times 10 to the 5th. 9.62 times 10 to the 5th. All right, zero in on that exponent. Is it positive or negative? Positive. Antoinette says it's positive. That's correct. If the exponent is positive, which way am I going to move? I'm going to move it to the right. Why? Because I'm going to make a big number. Positive exponent equals a big number, so I'm going to have to move this to the right. So I can take 9.62 and go 1, 2, 3, 4, 5. I have 3 empty spaces that I need to fill in with 0. And so I'm going to have 962,000. Okay? And make sure that you guys use your commas. I got people who aren't using the commas every 3 digits, and it is making the numbers very difficult to read. All right. So those were two examples where we have positive exponents. Now let's look at the other way. If you look at example 2 there on page 52, it is slightly different. We have 3.27 times 10 to the negative third power. Now, using those hand signals that we already did, we had associated a small number with a negative exponent. Now, if I look at 3.27 with a negative exponent, which way do I have to move it to make it a small number? To the left, okay? So I'm going to move it to the left 3 times. 1, 2, 3. All right? And I have to fill in the zeros. Now, because the decimal point is in the front of my number, I have to include that in my answer. I can do 0.00327, and I would say that that's a pretty small number. So small numbers match with negative exponents. And you'll find this to be true when we start going the other way as well. When they give me something that is a really small number and want me to put it into scientific notation, we can remember that clue. This is a really small number, therefore, I'm going to have a negative exponent. All right? So, which is a good point. Devin said that's 327 what? Okay, over 100,000, right? Now remember, what is 10 to the negative third? We've just been working on this, right? 10 to the negative third is the same as?
1 over 10 to the third power.
Right. 1 over 10 to the third power, which is the same as 1 over 1,000. So that's where all our extra zeros come from in the denominator. All right, let's look at one more. We have 2.85 times 10 to the negative fifth. Tell your neighbor what you think the answer to this one will be. Okay, the answer should be 0.0000285. Okay, so remember, I have a negative exponent, which means I'm going to be creating a small number. I'm going to do that by moving my decimal point to the left. Okay, there are goddess in the middle of the page. Okay, right in the middle of the page, A, B, and C. Goddess A, B, and C, get those done now.